Exciting earthquakes. The study of earthquakes is called seismology, and as we know from our unit on plate tectonics, most earthquakes occur at plate boundaries. Can you remember what kind of plate boundaries cause most earthquakes? If you guessed transform, give yourself a pat on the back. So when an earthquake happens, it sends out seismic waves. A seismic wave is just a wave of energy that travels through the earth. These waves travel in two ways: body waves, which travel through the inside of the earth, or surface waves, which move along the top. As you can see from this graphic organizer, there are two types of body waves, which we'll get into next. There are two types of body waves. P waves, or pressure primary waves, travel through all states of matter, solids, liquids, and gases, and they travel the fastest. They are the first ones to be detected by seismology machines, and these move the rocks back and forth. The second kind of waves, or S waves, which stands for shear or secondary, cannot travel through liquid. They are the second fastest, and they move rock from side to side. So here we have an example of P and S waves. A quick review: P waves move the rock back and forth. Think of a slinky as if you were pushing it in one direction back and forth. Put your finger on which one you think is the P wave. If your finger's on the top one, you've identified it correctly. The bottom one is the S wave. It moves rock up and down, hence that S shape. The second kind of wave are surface waves. These happen along the top of the earth on the surface, and they can move rock in all directions, up and down and back and forth. They move a little bit slower, but these are more destructive because think about it. On the surface is where all of our buildings are and our people live. So how does a scientist measure these earthquakes? Well, they use a seismograph. The seismograph is the instrument or the machine that records the movements in the earth. You can see a picture of one here in the bottom right-hand corner. The seismogram is the actual tracing. So in this picture, we see what looks like a needle, and during a vibration, it jiggles back and forth pretty fast. And so it makes the seismogram, which is the reading to show how big the earthquake was. An earthquake begins inside the earth. This is called the focus. This is the point where the plates actually rub against each other. But because we don't know exactly where that is or can't see it, we refer to the point on the surface as the epicenter. And this is what you usually hear reported in the news. An earthquake was felt in San Francisco today. So in that case, San Francisco would be the epicenter because that's where the direct shaking occurred. So in this picture, we see the 2 points of an earthquake. The focus is down inside the earth, and that black line going across the box represents where the two plates meet at the transform boundary. The dotted line that goes up to the epicenter is where we feel it on the surface. Earthquakes are then measured using the Richter scale, and this is a ranking similar to scales that we've seen with other things we've studied in here, the Mohs hardness scale, for example. This is just a ranking of the degree of the damage of the earthquake. So the Richter scale goes from 1 to 10, and each of those numbers represents what we call a magnitude. So the lower the number, the less severe the earthquake is. So if you look at the bottom of the chart, anything that's like around a 2 or a 3 is usually not really felt. People can't feel it. Machines can pick it up though. But the higher up you go, the stronger the earthquakes. Obviously, we can feel those. The other thing that's interesting is looking at this chart, look at the third column that says number per year. Again, if you start at the bottom with the lower numbers, you can see we have thousands of earthquakes every year. Most of those we never feel because they're so small. And as you go up the chart, the stronger earthquakes get less and less, thankfully, because those are the more dangerous ones.
There are times when the Earth isn't as stable as it seems.
And it just kept coming, and it kept coming, and it kept coming again. And it was like riding a roller coaster. It was really a rocking and rolling. I just, in my wildest imagination, had no comprehension that Mother Nature could be that destructive in just,
Every year, more than 1 million earthquakes rattle our world. We don't notice most of them, but the ones we do give us new respect for our planet. Earthquakes happen when tension stored in the Earth's crust is suddenly released. To understand what causes these disasters, we need to travel to the center of the Earth. The enormous heat and energy here shapes the layers above, especially the Earth's outer crust. We can think of the crust as a jigsaw puzzle divided into about 12 tectonic plates. These giant slabs of rock hold the continents and the ocean floor. For millions of years they've been drifting and colliding, pushed by the churning liquid mantle below. When they slip, grind, and crunch past each other, disasters occur. Some of the worst quakes happen when the plates get stuck and pressure builds. When they finally break free, energy is released as waves traveling through the ground. Geologist David Schwartz describes the process.
The plates are moving past each other, they're pushing against each other. When the stress builds up to a critical point, they snap, and the snapping of the plates basically produces the seismic waves that's the earthquake.
These disasters usually occur at the boundaries between two plates. This is where we find faults, cracks and fractures in the Earth's crust where the plates inch along. Geophysicist Ross Stein explains.
These faults, typically at their base, let's say 10 miles down, are moving at a few inches a year. And when that earthquake occurs, when that rupture begins, that fault, that motion is going to accelerate from a few inches a year to about 5,000 miles an hour. And it's going to do that in 3 seconds. So this rupture of the fault is a catastrophic process, unlike hardly anything else in nature.
Like ripples in water, the vibrations spread out in all directions, shaking everything in their path. The strongest shaking occurs at the epicenter, the place on the Earth's surface directly above the spot where the earthquake began. One of the worst quakes on record struck Alaska in 1964. It measured 8.5 on the Richter scale, a scale that measures the magnitude of a quake. The shaking lasted around 4 minutes, which is a long time for an earthquake. The ground ripped open, and in some places sank more than 50 feet. We know how earthquakes happen and the great destruction they create. But unfortunately, we still can't predict them.